This guy really needs to stop dancing. Not just because he's terrible, but because the world is running out of helium. But what does that mean for the Large Hadron Collider, MRI machines, and the new space race to mine the moon? Because it turns out helium is way more interesting than balloons. It's actually essential to our modern way of life. And the fact it's running out, well, that is a very big problem. So why is it running out? Well, let's start at the beginning. The very beginning. Right back to the Big Bang. Well, a few minutes after it. That's when the first protons and neutrons collided to form hydrogen, which then fused into the very first helium nuclei. This fusion of hydrogen to helium is in the core of every single star in the universe. And this fundamental reaction paved the way for the creation of all other elements. But even today, 13.7 billion years after the Big Bang, helium still makes up about 25% of the entire universe. So again, how are we running out of it here on Earth? Well, for all its abundance in the universe, it's actually very rare on our planet. Not only that, but it's the only element light and unreactive enough that it can escape Earth's gravity and leak out into outer space. The other issue is that we're using it up.
At the current rate that we're using helium, there have been estimates of about a 100 to 200 years supply. It's the very definition of a non-renewable resource.
So what are we actually using it for? Well, for one, this. The touchdown tradition of the University of Nebraska's American football team, where they released thousands of balloons after the first touchdown. Go Cornhuskers? Okay, we'll come back to this seemingly random example in a minute, because it's actually surprisingly relevant to the story of helium. But helium itself plays a fundamental role in the world today. It's essential in everything from space exploration and quantum computing to medical equipment and the Large Hadron Collider. Its extremely low boiling point means it's perfect for cooling down supermagnets. Meanwhile, its non-reactiveness makes it perfect for producing the semiconductor chips that go into just about every computerized device on the planet. Whatever you're watching this on almost certainly used helium to make it.
Imagine a world without helium. We wouldn't have MRI instruments for medical diagnostics. But also imagine all the things where computer chips are used. Imagine that whole industry was unable to function if we didn't have this special substance.
And that makes the fact that it's running out a pretty huge deal. So much so that the University of Nebraska tradition I mentioned,
Touchdown pass!
Yeah, well in May 2022, this 60-year tradition went on hiatus, and all because of the helium shortage. So thanks Nebraska for taking one for the team. But how on earth have we got to a point where we're relying on college football teams to pitch in and help a global shortage? Well, that story begins with the US thinking helium would win them the war. Yeah, back in World War I, the Germans had hydrogen zeppelins. The US military was jealous. So when a different light gas, helium, was discovered on American soil, they started to store huge amounts of it in a cave in Amarillo, Texas. The National Helium Reserve was born. But fast forward to the 1990s, and the US government decides, time to privatize this bad boy. So it dumps helium onto the open market, cheap helium for everybody. Problem was, that left no incentive for companies to produce their own helium, or recycle any they already had. Enter Helium Shortage 1.0, circa 2006. And since then, we've been hit by shortage after shortage.
Today, there are 4 major suppliers of helium: the US, Qatar, Algeria, and Russia.
To make matters worse, many of the world's helium plants were struck by disasters or political unrest in 2022. Welcome to Helium Shortage 4.0. And just to throw another curveball in the mix, the US government put the rest of its helium up for sale in 2022. So what happens now?
This is a very difficult thing for us to imagine. We would be ceding control of our helium resource to a private entity. We don't even know if helium will continue to be stored there.
So if not there, where? Most of the helium left on Earth that hasn't already escaped into space has been trapped in the Earth's crust.
In many cases, helium is extracted as a byproduct of natural gas. But in Arizona, helium exists in these geologic layers alone.
So for some, The answer is to mine for helium.
What happened in 2018 is it got listed as a critical mineral, and that sort of elevated its status for extraction. So new permits are being issued for helium actively now.
But it's already proving contentious.
In Arizona, the land surface rights are owned separately from the mineral rights underground. So a landowner can have the mineral rights sold from underneath their feet to a company that wants to come drill and extract. We are now at the beginning of modern helium extraction, and so there are no studies on what the environmental impacts are.
So who gets to decide about the extraction process?
The same kinds of stories that the nation, the federal level told itself and others about uranium, it is now telling about helium. And so if national security is the most important thing, and we're in wartime and we need to protect our citizens, then mining X element, whatever it is, to support that national security and defense is the highest priority. If you're living on the land and you care about your future generations and your children and your water and your security, then not mining and not risking extraction impacts at all is the most important priority. I, as an environmentalist myself, have been convinced that there are safe ways to extract helium.
So we need more helium, but we also need to stop our reliance on fossil fuels. Not to mention a checkered history, to put it mildly, of marching into protected environments and mining them to death. And it's not going to get any simpler, because now we found an even more exciting use for helium.
Helium-3 has been identified as a potential fuel for what's called fusion energy.
Okay, time to get technical, because up until now we've been talking about a specific type of helium, helium-4. Now I want to introduce you to helium-3, an isotope with just one fewer neutron in its core, but that one single neutron makes a huge difference between a supercooling liquid and a potentially game-changing source of energy.
Right now, the way that we obtain nuclear energy on Earth is by fission. You hit an atom, you split it, and in the process, you generate energy. Fusion is totally different. Here, you bring two elements, two particles, and you fuse them. And in the process of doing that, which requires a lot of energy, then a lot of energy is also released, and is released directly into electricity. You don't have to go through heating, and then steam and then producing electricity. It directly goes into electricity. And even better, the residue is helium. Just helium, the one that, again, you can use for inflating balloons. So it's a non-radioactive waste.
Cool, so where do we get helium-3 from? We have a little bit on Earth, including some from dismantling nuclear weapons. But it turns out there's another source of it. Here.
Helium-3 comes from the sun, and that accumulates on the moon at larger quantities that we find here on Earth, because our magnetic field protects us from there.
Overall on the moon, there's estimated to be about 1 million tons of helium-3. And that tantalizing treasure is sparking a whole new space race to get back to the moon. Leading the race are the US and China. China is already searching for helium-3 in lunar rocks brought back in 2020. And they have plans to launch a robotic lunar mission in 2025. Meanwhile, NASA's Artemis program will see humans set foot on the moon again in 2025 to explore the satellite's south pole. So whether it's mining the moon for helium-3 or trying to preserve the helium-4 here on Earth, you're probably about to hear a lot more about helium in the coming years. But does that mean we're just done now for helium balloons? Well, not necessarily.
Those party balloons touch more people's lives and make more people care about helium than they would about other noble gases. You know, nobody's really excited about argon for the most part. And so really helium is special. And again, if we look at it as this special, almost magical substance, then maybe we can see that it's really a gift of the universe to us to have this thing that allows us to lift balloons and also power rocket ships. What else on Earth can do that for us? So I am not a balloon denier. This is how I put it. I think that people see the magic in helium and it should be shared.